lecture for today is definition of the derivative. The derivative is just the slope of the function. That's all it is. But it's kind of tricky to find, so that's why we have a semester trying to figuring them all out. So let's start. Suppose we have this function, and we want to find what the slope of the the slope of the tangent is right here. The slope of the curve, that's called the slope of the curve. To do this, we're going to draw a secant line that goes through that point and figure out what the slope of that line is. Well, to do that, to find the slope between these 2 points, I need to think about this one, which is a comma f of a, and this point, which is a plus h, and the y value is f of a plus h, where the distance on the bottom is h, and the distance on the side is f of a plus h minus f of a. So the slope of that line is f of a plus h minus f of a all over h, rise over run. So what we're going to do to find the derivative at that point, or the slope at that point, is make h smaller and smaller. We bring that point closer and closer to my a. So eventually those blue lines will give me, will give me the slope of the tangent. So what I'm doing is taking the limit as h approaches 0 of that hideous f of a plus h minus f of a all over h. So the notation is f prime of a, and that stands for the derivative of f of x at x equals a. That's why we've been doing all these limits, because this is in our future. So let's see if we can look at some graphs and figure out what some derivatives are. If we look at this function, looks like at x equals 1, the slope pretty much is flat. And if I draw a tangent, that tangent looks pretty flat. So we're going to say that the slope at 1 is 0. So f prime of 1 equals 0. It also looks like the derivative at 6. That looks like the derivative there is also 0, but I didn't draw a pretty red line. What if we want to find it at a different point? What if I want the derivative here? If I want to estimate it, I will draw a line and make that line as tangent as possible. You know, we're only human, can't be perfect. It's clearly got to be negative. So if you estimate this and get a positive slope, you did something wrong. So now that I've drawn my tangent, I want to figure out the slope of that line, and it appears 1, 2, 3, not quite, but we're going to still call this 3. So 3 down and 2 over. So rise over run, we get negative 3 over 2. So the derivative at 2 is negative 3 halves. We want to be able to find the derivative at every point, and we certainly don't want to draw these lines all the time. The derivative of the function is defined to be the limit as h approaches 0 of f of x plus h minus f of x. So let's crank out, see if we can find some derivatives. The first function I'm going to look at is x squared. So we have the definition of the derivative over here, and I need f of x plus h, which means x plus h gets plugged into the function over there. Oh, that arrow's annoying. So we have x plus h, quantity squared, minus x squared all over h. If you plug 0 in for h, you'll get 0 over 0, and that's not cool. That's the weird limit, so we need to jiggle it to figure out to cancel something so that we get a real number, a normal number. So I'm going to have to multiply that x plus h squared out. So I'll get x squared plus 2xh plus h squared minus x squareds. Notice the x squareds subtract off. There's positive, there's negative. And the leftovers both have an h in them that we can suck out and cancel with the bottom. So here we have our h's that we've sucked out. We can cancel them. I'll be left with 2x plus h. And when I stick 0 in for h, I'll be left with just 2x. So the derivative of x squared is 2x. So let's try another one. Suppose we have the square root of x plus 3. Again, I just threw the definition there. The more times you see it, the more likely you are to memorize it, because you will need to memorize it. F of x plus h gives me the square root of x plus 3 plus h minus the square root of x plus 3 all over h. Again, if I plug 0 in for h, I'm going to get 0 over 0. I need to jiggle this somehow so that my h's cancel. I'm going to do this by multiplying by the so-called conjugate, the square root of all that crap plus the square root of x plus 3. So we multiply through the top, we'll have x plus 3 plus h minus quantity x plus 3. And on the bottom we just have a mess, and we're going to leave it there. We do not want to run that h through because we're going to cancel it in a minute. So notice how we have a positive x here and a negative x here, so they're gone. Positive 3, negative 3, when I run it through, they're gone. The only thing that survives on the top is that h. And now this h and the one on the bottom cancel, and I can plug into the leftovers. I have, oh, I just canceled. So if I plug into the leftovers, I don't have an answer. There it is. I have two of them. 1 over 2 squared of x plus 3. So this is known as finding the derivative the oogie way. That's really not the mathematical name for it. That's my name for it because it is kind of oogie. Next time we'll learn all these tricks and shortcuts, but you're going to have to be able to find a couple derivatives doing it the long oogie way. It's good for you. It builds character. So that's all of this lecture, and I will do more later, and I don't know how to end this. So ta-da, that's the end.